So our next speaker is going to be Vikram Chatterji, and we were trying to see, I was trying to determine, is he the youngest speaker on stage today? So it was a close call between him and Vedant, but I still don't know which one of them is younger. But he definitely takes the gold medal for being the youngest IIT on stage today. So a high schooler just asked me, how do you build agents that really work? That's a great segue into our talk by Vikram. So Vikram, please come up on stage. He is the co-founder and CEO of Galileo, also a sponsor for our conference today. Thank you.
Thank you. Thanks so much. Hi, everybody. Good afternoon. Seems like this thing is working. Just click. All right. So yeah, I'm Vikram Chatterji. Good to meet everybody. I'm the co-founder and CEO at Galileo. We have actually been around for about 4.5 years as a company. We're Series B, around 90 people, based out of Burlingame. We have an office in Bangalore. But what's interesting about the company is that we've been always obsessed about language models for the last 4.5 to 5 years. And even when we started out, we were called the Deep Learning Ops Company, which is now obviously much more about AI. So what I did want to talk about today was just what does that journey look like all the way from, I'm going to start all the way from around 15 to 17 years ago, and then come back to now about why people are talking about agents. And why, when you read reports like the one from MIT's review recently, where it said like 95% of agents are actually, they fail in POC land, that was not a surprise to us. In fact, our question was, who are these 5%, which is actually working? Because most agents that we see, they actually don't work. So the question is, how do we now move towards the next phase of just enterprise software where agents actually start to work? And that's exactly where Galileo has been working for the last 4 or 5 years. I thought I'll just share first just going back into history of like about a decade and back, and then coming back to where we are today and why agents are not working and where I think things are going from here. I wanted to start with this because way back, Andrej Karpathy, if folks don't know, is a really famous researcher now. He was in Fei-Fei Li's lab and then Chris Ray's lab. And he had written this post back in 2017 about Software 2.0, which was extremely inspiring to me and my co-founders, because this is something that we were seeing. So I'll talk about this in a second, but I was leading product management at Google AI, and I was thinking about exactly this, because when neural networks came about, the earliest neural networks came about, they were considered deep learning, it was considered research, but folks didn't really understand how powerful they were and how much they were starting to be used and blended into software. And Andrej's post went viral because he's very good at coining terms. So he called this Software 2.0, and everyone loved that term. But this point at the bottom where he said that neural networks aren't just another classifier, which is what everyone thought about that entire domain of work, but they actually represent the beginning of this huge shift in terms of how people even just write code, right? And so that was in 2017, so it almost took a decade for us to now all be talking about cursor and how the fundamental way in which we're writing code is changing. But if I go a step back, so I was at IIT Guwahati about in 2010 batch. I'm not sure how much of representation there is from IIT Guwahati here. I see a few hands, so great. But while I was there, I actually started working doing my internship at CMU, and I just accidentally fell into this lab, which was working on natural language processing there, and I just fell in love with this concept of building these bots which can just talk to human beings in a very natural way. So I went back there again and then joined Google, and over time started working fell again into this team of really nerdy researchers who were working on the transformers technology. They just open sourced a model called BERT, which is one of the first large-scale natural language models. And my team was essentially working with Fortune 500 businesses to build some of the first large-scale natural language applications, right? And it was extremely painful. If you feel like working with AI today is hard, that was even harder. It was very manual. So that's kind of why Galileo started, because we thought of it as, in the future, going forward, we started Galileo in 2021. So we started thinking like in the future going forward, Software 2.0 really has to become a thing. That means every developer is going to be building the way we were at Google, which means they're going to face the same problem. And what we realized was the existing SDLC stack that you have, right? Like think of everything you're using for testing, Datadog for monitoring, all of this stuff, everything is going to have to change. It's fundamentally just different, the way you write software. And our thesis then and now has been, eventually all of software is just going to be AI applications. It's always all going to have this intelligence of the operating system at its core. It's all going to be exactly that, in which case, who's going to build this entire tool chain for testing, monitoring, and also millisecond guardrailing of your AI applications? And that's what Galileo does today with a host of companies, and I'll get to that. Now, just to take another quick step back, what we're seeing in the market across, while we've been doing this for about the last 4 or 5 years, is two really interesting trends that have been taking place in terms of when you contrast software 1.0, which is classic development with if-else statements, and then software 2.0, which is coming up now with a lot of ferocious velocity. One is when you think about slightly complex applications, right? Like if you think of a multi-agentic application or some application for customer experience, what we've been seeing is over the course of time, even the last 1 or 2 years, the amount of time that it takes for a developer to actually build out some of these complex applications in software 2.0 is reducing. Like Bratin was on stage talking about DigitalOcean's platform, which is one of those amazing platforms which has actually really bridged the gap for developers to almost just enter natural language to build very complex applications. Versus if you look at software 1.0, the more complexity in the application, the more APIs you have to use, you have to stitch them all together, and the complexity starts to actually increase as over time. The second thing that we've seen, though, which is a bit of a paradox, is even if the build time increases for a very complex software 2.0 app, these AI applications, the utility isn't quite there yet, right? So folks are trying to build these really complex applications in the enterprise. We work with the largest banks. We work with dozens of Fortune 500 businesses today. And what we're seeing is they just are hitting this ceiling where they just can't get the utility out of these agents to work, right? Versus with traditional software, it's much more deterministic. It's just you build it, you ship it, it works. You might hit some bugs. You know how to work with those bugs. It's very simple. But very quickly, they start hitting this ceiling. So the question became, why is this fundamentally different? And the answer is, again, Bratin had mentioned this too, software 2.0 is just non-deterministic. So everyone is grappling with this idea. Developers are grappling with this idea of, wait, I'm trying to ship something which inherently is non-deterministic. And now the question is, can I make this deterministic? How can I put some guardrails in place where I know there are failure modes? How do I even identify that? So again, now we're seeing what the problem that I had at Google, we're seeing this happen across the entire globe, across developers in the enterprise. Like what's the tool stack look like for making sure that this is successful? So overall, if you look at, slightly messed up over there, but AI applications are just very complex, and they're non-deterministic systems. And essentially what we've been seeing is the reason for this is because if you look at the inputs and outputs overall, the number of failure modes are just incredible. Like when you're seeing these kinds of inputs coming in itself into the application, there can be injection attacks, they could be non-compliant, they could have different kinds of poor context chunking, there's different kinds of tool error rates that start to happen. In the response itself, there's hallucinations. A lot of banks that we've worked with, just before they launched things in production, they started to see that the application was spewing out a lot of PII, prompt injection attacks again on that side, and there are vulnerabilities from a policy perspective. So if you look at the number of failure modes that, because of which a person might say that, hey, my agent doesn't work, it's actually a lot. It's a large surface area to cover. So how do you actually do this failure mode discovery? How do you root cause analyze this agent? How do you block this, and how do you fix this? All of this is actually very, very hard. It's a very, very hard problem right now for developers everywhere. Whoever is building agents, I'm not sure if your teams and companies are building out AI agents today. If you talk to the developer, they'll probably tell you that they'll build it. It's becoming faster and faster to build. But how do you make sure that you can actually trust it? And how do you make sure that it is reliable in production, at scale? That's the bar that we have to all cross collectively. Now, what's also happening is very quickly these companies go from one agent that they productionize to 10, 20, 30, because again, it's becoming easier to build them, but it's becoming harder and harder to get utility out of them, right? So the proliferation of agents across different companies and different teams has been increasing. And then on top of that, we're also starting to see my past team at Google, they've been working on this agent-to-agent protocol. It's called A2A. And Galileo also worked with Cisco to come up with another protocol for agent-to-agent communication, because we do think this is the future. We're moving towards this world where we'll have not one monolithic agent for one massive use case. We'll actually have many different micro agents. It's almost like the microservices architecture, and they'll all be talking to each other, right, to complete an entire task. And once this starts to happen, and once we actually can do this in a very meaningful way, that literally changes the way software works, it changes the way we all work. And that's what we are very excited about. But when you take a step back and think about from a developer perspective, how do you make sure that these multi-agentic systems that are talking to each other, that they have different authentication protocols, et cetera, how does all of that complexity get harnessed in one place? So we actually released, at Galileo, we did this experiment where we released our free SaaS version of Galileo. So if you go to galileo.ai, we basically said we've built all of this evaluation system where any developer can go and test out their agents. So we said, fine, we have agent evaluations. We can, if you're building an agent, you can easily add Galileo with your few lines of code, and you can start to see what's going wrong with your agent. You can get a full root cause analysis. So we launched that for free, and we started to see the number of net new signups just went through the roof. We were very surprised by this because we were not marketing this at all as much, the free version, but we started to see people just come in and started to do a lot of runs, hooking up their agents inside of Galileo. It was absolutely incredible to see. And so this was another big indicator to us of two things. One, more and more agents are actually starting to be built. The number of use cases for agents are just absolutely incredible. And number two, almost all of these developers were hitting this wall of, wait, how do I even know this is working very, very quickly, right? And that was fueling all of this demand for this. So when we think about the entire, what I call the ADLC, and Bratin mentioned the same thing, it's the agent development lifecycle. It is fundamentally different than the traditional software development lifecycle, but it's the same people, it's the same developers doing this. So what does it mean in terms of the tool chain? So the tool chain that we've built out at Galileo is, and you can see all of this more and more at galileo.ai, but it's three different parts, right? How do you test things? How do you rapidly experiment? How do you rapidly create regression tests in one place? How do you then go and start doing real-time monitoring, not for 5 or 10% of your traffic, but for 100% of your traffic? Number three, how do you do root cause analysis of all of this using an insights engine? And then number four, protection, which is if you know what's going wrong, if you have some policies in place, how do you, within 200 milliseconds and with a couple of cents, not dollars, how do you block an agent from doing something which is harmful? So all of this right now is powering some of the largest enterprises in the world already. Galileo has been live with, obviously with DigitalOcean, which is a very close partner to us. We are embedded inside of DigitalOcean's Gradient AI platform using our APIs, which has been incredible to work with them. We're also live with a lot of banks like JPMC, American Express, Verizon, Comcast, et cetera. And it's been such an interesting journey to see these developers at these companies go from one RAG-based application to an agent, and now they're all talking about how do I go from 1 to 100 agents in production in a very deterministic fashion. And so if this is starting to happen in the largest enterprises, and we're super excited about what 2026 starts to look like. What we're seeing overall, right, when I started talking about this, we went from software 1.0 to 2.0, and Andre Karpathy talked about this in 2017. The same Andre Karpathy now has been talking about software 3.0. He's very good at coining these terms. So basically what this means is how do you go from software 2.0, which was all about embedding these neural networks inside of the way you code, right, to software 3.0, where increasingly what we're seeing is the bar to become a developer is reducing. You just have to know how to write natural language, right? Including, like you can see with platforms like Gradient AI, ServiceNow has a similar kind of platform, Crew AI has a similar one. So we're seeing this increasingly happen where if you want to build a very complex agent, build it. It's just natural language. It's very, very quick to do that. So that's the massive shift where the AI itself is going behind the scenes, allowing anybody to build very, very quickly. So this is an extremely exciting shift. How do you go from software 1.0 to 3.0? But the big question becomes, how do you make sure that you can test things, regression test, root cause analysis, monitor, and then guardrail them all in one go so that you can actually sleep at night knowing that it's reliable and it's not harming your brand and it's not harming your users. So this is a big shift that I think all of us are going through right now. Been talking to some folks separately about this exact point. I'm very passionate about language models. As you can see, I've been thinking about this and working on this stuff for the last 15 to 17 years now. So if you're building out AI applications and agents in your company as well and facing similar problems, I would love to nerd out about that and talk more. So thank you so much.